This is Ham College, episode 96 for December 30th, 2022. This episode of Ham College is brought to you by ICOM. Didn't get everything on your wish list? Spice up your ham shack with one of ICOM's popular handhelds, mobiles, or base stations. Good evening, everyone. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we have questions. Have you got answers?
I have answers. I don't know if they're going to be the right answers, but I do have answers.
Well, that's optional. These questions, I don't think, are as hard as the ones we've had in recent episodes.
Well, that's great news.
Well, it is.
Late Christmas present.
What did we talk about last month?
I was just thinking about that. We talked about filters, matching networks, types of networks, types of filters, filter applications, filter characteristics, impedance matching, and DSP filtering. Lots of filters.
Lots of filters. And why I said what I said earlier is tonight we're going to be talking about power supplies and voltage regulators and solar array charge controllers. That does sound a lot easier than all those.
That sounds like a lot more fun than the filters.
Anytime we're shooting an episode live, we've got a chat room going on as well. And especially during this show right here, it's kind of handy to have that chat room there because we'll ask the questions here and see how everybody does over there, and we'll compare our answers with theirs.
You get graded right on the spot.
Mm-hmm. Yeah, too bad we can't grade on a scale.
Yeah.
But, hey, I think they're going to do well tonight. I think you're going to do well, too.
I hope so.
First question for tonight. How does a linear electronic voltage regulator work? A, it has a ramp voltage as its output.
B, it eliminates the need for a pass transistor.
C, the control element duty cycle is proportional to the line or load condition.
Or D, the conduction of a control element is varied to maintain constant output voltage. Does a linear electronic voltage regulator work? Doesn't have ramp voltage on the output. It's supposed to be constant. Eliminates the need for a pass transistor. No. Control element duty cycle is proportional to the line. No. I'm going with D. The conduction of a control element is varied to maintain the constant output voltage because that's the whole purpose of the linear voltage regulator.
Well, based on what everyone is saying in the chat room, you're right. I'm going to agree too. It is D.
Well, it started off pretty good. Let's see if we can hold it.
Yeah.
Okay. Yeah, we haven't done that in a while.
Yeah, we haven't. Really hadn't been as much need to in the last couple of episodes, but yeah.
Yep.
Get them when we can. Well, let's just talk a little bit about a linear power supply or voltage regulator. Here's one right here. Starts out like any other power supply. We have a transformer to couple that AC line voltage over to our circuit and generally drop the voltage there to whatever we want. Then we got a rectifier. That can be a single diode or up to 4 to make a bridge rectifier. In this case, it's a bridge. We've got a capacitor right here, and I was about to say what that's for, but I don't think I will because that may be one of the questions. And so I won't say what this one's for either. But here's a simple regulator right here. This is a 3-terminal regulator. In this case, you can find these things all over the place, like part numbers like LM7812, or in the case of a negative voltage regulator, it'd be a 7912, or whatever voltage you're looking for. They come in transistor packs like this.
I've
And
got quite a few of those at the house laying around.
I got a whole drawer full up there of different voltages. You put in a voltage a little higher than what you want to get out, and it clamps it down and gives you the voltage that you're actually wanting. Pretty convenient, eh?
Mm-hmm.
I
Yeah.
remember when those came out, man, that was really nice.
Yeah.
Yep.
Pretty convenient, easy to use.
Yep. Okay, next question.
What is a characteristic of a switching electronic voltage regulator? A. The resistance of a control element is varied in direct proportion to the line voltage or load current.
B, it's generally less efficient than a linear regulator.
C. The controlled device's duty cycle is changed to produce a constant average output voltage.
Or D, it gives a ramp voltage at its output. Let me go over the wrong ones first. It's not D. You know, if you're looking at a regulated power supply, you're not going to want a ramp voltage coming out of it. I wouldn't think. So we're just gonna throw that one out altogether. A, the resistance of a control element is varied in direct proportion to the line voltage or load current. Not in a switching supply, no. B, it is generally less efficient than a linear regulator, no. It's not. It's quite the opposite. So I'm going to say it's C, the control device's duty cycle is changed to produce a constant average output voltage. Chat room? Yeah, they're saying C. What do you think, Dean?
I think it's C.
Okay. And it is. Here is a simplified switch mode power supply. Our main input, AC voltage. We go to a rectifier and filter just like we did on the linear supply. But then here's where it changes. We've got a high-speed switch right here. Then we've got an output transformer. So it's coming into this DC, and then this inverter or chopper or switch is switching the signal on and off with pulse width modulation. It may not be as high an on period as it is an off period, just depending on the voltage. Then we got an output transformer because that pulse DC is going to kind of act like AC. So it will pass through a transformer. And then we've got a rectifier and filter, and we go on to the output. There's feedback from that, though, into a chopper controller here or a pulse width modulator. And that's what sends the PWM signal to the chopper or inverter or switch to tell it what the duty cycle is and how much of the period the voltage should be high and how much it should be off. And by varying that, and I think we've talked about this before, but by varying the on time of that pulse, by the time we go through that transformer and through the output rectifier and filters, we've got a lower voltage. If it was switched on the whole time, we'd have the full voltage at the output there, but since it's not, it's a fraction of it.
You know, you've watched too many 80s movies when you hear somebody talking about to the chopper and you think of Arnold Schwarzenegger. To the chopper.
Okay.
You don't remember that?
No, I
Okay.
hadn't really put that together. So glad you pointed that out. I could have missed it.
Yeah, you probably would have been okay without it,
Yeah.
though. That's
Oh.
pretty cool. It's pretty cool concept how that works.
It is, and that's a very simple view of it that I gave right there. And reality, yeah, they got a lot more stuff going on in there, or can. A little hard to work on, but I can say now I have successfully fixed at least one of them.
Yeah.
Yep.
You did get it. You did get it repaired.
Yeah, it was my Astron
Oh, the one we were talking
SS30.
about earlier.
Well, before the show, you and I were talking about it. You know, it broke, and it sat on my shelf in pieces for months and months and months. And I was ready to throw it away, and I decided to give it one more try. So that's how that went. Well, I've got another question for you.
All right, hit me.
So far, everybody's doing good on these.
So
I thought
far.
they would. What device is typically used as a stable voltage reference in a linear voltage regulator? Is it A, a Zener diode,
B, a tunnel diode,
C, an SCR,
or D, a varactor diode? If I said that right.
mm-hmm.
What device typically used to get a stable voltage reference? This one is going to be a guess, but I think I remember it's, or it seems like I remember. I think it's a Zener diode, but I'm not 100% positive about that.
Okay.
I'm pretty sure that's right, though.
Chat room is saying it's A. I'm saying it's A.
Well, it must be right then.
Why are you saying A?
Because it's ringing a bell.
Okay.
Do you hear it?
I thought that was your watch a while ago. But no. No, okay. I'm going to agree with you. It is A.
You got some splaining on that one?
I got just a minor amount of splaining.
Okay, that would be good.
This is a regulated linear power supply. Same thing we were looking at earlier. Transformer, bridge rectifier, capacitor. And there's a resistor here and a Zener diode. Rather than that 3-pin voltage regulator,
Mm-hmm.
we're actually going old school here and using a Zener diode. There's two different ways to do that. One is you just take the voltage right there at the Zener. The other is you can send it up to a pass transistor, but we'll talk more about that in a minute. But essentially, the Zener diode is the regulator. Back in the tube type days, yeah, we had tubes that could do this. When we got solid state devices and they developed the Zener diodes, you know, those were like start conducting at a specified voltage. So you just pick out a Zener for the voltage you're looking for, and you got to have a resistor in there too. But yeah, that simplified things a lot. A linear regulated power supply uses a linear regulator, which we looked at that earlier. Could use a Zener diode. It provides the desired output voltage by dissipating power in ohmic losses in a resistor or the collector-emitter region of a pass transistor in its active mode. A linear regulator regulates either output voltage or current by dissipating the electrical power in the form of heat. Its maximum power efficiency is voltage out divided by voltage in, since the voltage differential is wasted heat.
Which of the following types of linear voltage regulators, which of the following types of linear voltage regulator usually make the most efficient use of a primary power source? A series current source.
B, a series regulator.
C, a shunt regulator.
D, a shunt current source. Which of the following types of linear voltage regulators usually make the most efficient use of the primary power source? Well, I happen to know the answer to this one, but I'm going to give them just a moment in the chat room. Somebody else might have a better answer than me. What do you think?
I think it's B.
I think it's B. All of us who are thinking and actually publishing our answers are saying B.
Okay. A lot of them holding back.
Yeah. Yeah, it's only a handful out of the chat room that are actually answering, or the number of people watching. You know, And let me just say at this point, because we don't often say it, but to be able to participate in the chat room there or make a comment, you've got to, what have you got to do? There is a requirement.
Yep, you have to be subscribed to the channel for more than 5 minutes.
Yep. And we're not doing that necessarily to force people to subscribe. It's just really the only way we can moderate the chat room.
Yeah.
If we don't do that, well, you end up with spam and stuff.
Yeah, when we had it wide open,
Yeah.
it a couple times got a little ugly in there, so we had to do that to kind of tighten it up a little bit.
It did. So, B, a series regulator.
That's my final answer.
And that's a good answer. Okay. What can we say about that? Well, we can tell you what a series regulator is. We've got unregulated DC voltage coming in. We've got a resistor here. In this case, we're going to use a Zener diode to clamp down that voltage to whatever we want. And then we've got a transistor. Is that an NPN or a PNP? What you think?
No idea.
That is a NPN.
How do you know?
How do you know? You see the way the arrow's pointing right there?
Yep.
It's pointed out. An NPN never points in. So since it's pointing out,
I'll get that next time.
Yeah, a guy I worked with at a TV station in Florida told me that. I mean, I knew what it was, but I didn't know that key for remembering it, and that sure made it a lot easier.
Yeah, that's a good way to remember.
So let's say that's a 12-volt Zener diode. And let's say over here maybe we've got 18 volts or something more than 12. Goes through that resistor. The diode here shorts it down to 12 volts right there because it starts conducting at 12 volts. And that's going to hold this point right at 12. You got to have that resistor right there. You can't do without that because otherwise you'd just be putting a short right across your power supply, and that's not good for you or for the diode or anything that's before it. So we're setting the base of the transistor right here at 12 volts. And you notice we've got this lead here on the collector that's back here at the input voltage. So if we set 18 volts, we got 18 volts sitting on that collector.
Mm-hmm.
We got 12 volts on the base right here. So out here on the emitter, well, it's going to regulate that voltage down to where we don't have 18 volts out here. We've got closer to 12. The voltage that's actually operating the transistor. Adding an emitter follower stage to a simple shunt regulator forms a simple series voltage regulator. The output load is supplied current by the transistor whose base is connected to the Zener diode. The transistor's base current forms the load current for the Zener diode and is much smaller than the current supplied to the output. This regulator is classified as series because the regulating element, the transistor, appears in series with the load. The voltage, the junction of R1 and the Zener diode, determines the voltage which will appear at the emitter of the transistor. This circuit has much better regulation than a simple shunt regulator since the base current of a transistor forms a very light load on the Zener, thereby minimizing variations in Zener voltage due to variations in the load. Note that the output voltage will always be about 0.65 volts less than the Zener diode voltage due to the transistor's base to emitter voltage drop. Although this circuit has good regulation, it's still sensitive to load and supply variations.
That's pretty interesting. That kind of makes you want to go get some of those parts and play with that.
You know, you can. It's very simple.
Uh-huh.
All you need is Just very few parts there. Which of the following types of linear voltage regulator places a constant load on the unregulated voltage source? A constant current source.
B, a series regulator.
C, a shunt current source.
Or D, a shunt regulator. Which of the following types of linear voltage regulator places a constant load on the unregulated voltage source? It's going to be D, a shunt regulator.
Places a constant load. The chat room's still coming in with some answers there. They are kind of all saying D.
Yeah.
A shunt regulator.
That's what I said.
Yeah. I'm going to agree with you. That's what it is. There you go. See, I told you you're going to.
Yeah. Yeah, I ran across that when I was doing the my battery build.
I was wondering how you went straight for the throat on that one.
Yeah.
Yeah.
Every once in a while, on some of those projects, I actually learn a little something on them.
Yeah.
If I don't, if I'm not careful.
It could happen. A simple shunt regulator operates by way of a Zener diode's action of maintaining a constant voltage across itself when the current through it is sufficient to take it into the Zener breakdown region. The resistor R1 supplies the current to the Zener as well as the load. This regulator is used for very simple low-power applications where the currents involved are very small and the load is permanently connected across a Zener diode, such as a voltage reference or voltage source circuit. The regulation of this circuit is not very good because the Zener current, and therefore the Zener voltage, will vary depending on the load current. This would be a good time. Take a little break. Come right back and give away something. What do you think?
Let's do that.
Happy New Year from ICOM. Didn't get everything on your wish list? Spice up your ham shack with one of ICOM's popular handhelds, mobiles, or base stations. These radios are perfect for working your favorite bands while staying inside or venturing out this winter. The IC705 is the perfect sidekick and QRP companion. Base station features and functionalities at the tips of your fingers in a portable package covering HF 6 meters, 2 meters, and 70 centimeters. This compact rig weighs in just under 2 pounds with RF direct sampling for most of the HF band and IF sampling for frequencies above 25 megahertz. 4.3-inch color touchscreen with live band scope and waterfall. 5 watts with the included BP272 battery, or 10 watts with 13.8 volt external DC. Single sideband CW, AM, FM, as well as full D-Star functions. The perfect accessory for the IC705 is the optional backpack LC192. The ID52A is a VHF-UHF dual band with D-Star and FM dual mode functions and is the first handheld radio with a full-color 2.3-inch waterfall display. This radio supports conventional FM communications and D-Star simplex, repeater, regional, and worldwide calls over the D-Star Internet Gateway. Create your own band opening with the IC9700. This radio brings direct sampling to the UHF-VHF weak signal world. The IC7300 is a high-performance HF transceiver with a compact design that will far exceed your expectations. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real ham fun starts here. Happy holidays from ICOM America, and visit icomamerica.com/amateur for more information on ICOM radios.
While we were gone, I found something.
Oh, you did?
Yeah. I found a shirt here. It's a cool Ham Crew t-shirt. ICOM Ham Crew t-shirt. They got the same thing on the front as it's got on the back, so you'll look just as good when you leave the ham fest as you did when you got there. That's what I always say.
And if you'd like one of those, it's very simple rules. All you got to do is send an email to hamcollege at AmateurLogic.TV. All you got to have is a name and an email address. You can put a little note in there if you want to. We'll read it here on the show if you're selected as a lucky winner. We did a random drawing really just right before the show tonight. I mean, like seconds before the show tonight. And we got a winner.
Yeah.
I don't know if he's in the chat room tonight or
I
not.
haven't seen him tonight. I've seen him
Okay.
in there before, though.
He says, "Hi, Tommy and George. I'd like to enter the swag giveaway. I hope y'all had a very Merry Christmas and a happy and prosperous New Year. 73D KD7 SJT Earl Grey."
I love your tea.
Yeah, me
Earl
too.
Grey tea.
Yeah,
Yeah, so congratulations, Earl.
yeah,
You're the swag winner of the month.
yep.
So Jesse will be getting in touch with you pretty soon and get your stuff sent to you.
So why not throw in your registration now? Doesn't even cost a postage stamp. Just drop us an email, hamcollege at AmateurLogic.TV. And you can be as stingy on the words as you want.
Yeah, but they
Up
are
to you.
free.
They are free now. Yep.
Cheap, they're compliant. Cheap old man compliant.
I guess you're right
So-
about that.
So anyway, the queue got cleared out, so send yours in for next month's drawing.
Yep. We don't save the names, so they're gone. We erase them as soon as we drew a winner. I think we got some more questions. These are going to have pictures with them.
Ooh, pictures.
That kind of helps out, doesn't it?
Sometimes.
I think
Depends on what the picture is.
it's my turn to answer.
Okay.
So here's the first one.
What is the purpose of Q1 in the circuit shown in figure E7-2? A, it provides negative feedback to improve regulation.
B, it provides a constant load for the voltage source.
C, it controls the current supplied to the load.
Or D, it provides D1 with current. What is the purpose of Q1 in the circuit shown in figure E7-2? Let's go over them here. A, it provides negative feedback to improve regulation. No. B, it provides a constant load for the voltage source. C, it controls the current supplied to the load. I'll come back to that one. D, it provides D1 with current. No, it is not there to supply D1 with current. I know it's not that, and I know it's not A, so it's B or C. C, it provides a constant load for the voltage source. I think it's C. It controls the current supplied to the load. I think that's it. My answer would have been it controls the voltage applied
Well, that's
to the
what
load.
I was thinking, because what we talked about earlier.
Yeah, that's not one of
But
your
C
choices.
seems like the next best answer.
Yep. So I'm going to say it's C. The chat room is saying that it's C, and it is.
Huh.
Because if it's controlling the current, it's controlling the voltage as well. What is the purpose of C2 in the circuit shown in figure E7-2? Same circuit. Is it A, a bypass rectifier? I didn't say that right. A, it bypasses rectifier output ripple around D1.
B, it's a brute force filter for the output.
C, to self-resonate at the hum frequency.
Or D, to provide fixed DC bias for Q1. Well, I know those caps are used for filters at times. Brute force filter. It's not C, and I don't think it's D. I'm pretty sure it's A or B. I'm gonna go with B. I'm not 100% sure though.
Okay. Well, the chat room is saying A, and that's what I'm saying as well.
Okay.
And it is A.
All right.
And you want me to tell you why?
Yeah, sure.
The key word in there that would help answer this one Well, you don't see the rectifier in there. But the rectifier normally is going to be right up there where it says plus 25 volts.
Okay.
Right up there. That's where the rectifier typically is in these circuits.
Also, the B says the brute force filter for the output. Well, the output's over on the other
Right,
side.
exactly.
So I should have caught that.
Exactly.
So that's my bad.
Yeah. So that's the two clues right there is to it's the location of it. Obviously it's the location of it, but that is coming right after the rectifiers, and it's not on the output.
Yeah, if I would have caught that, I would have got it, but I didn't.
You know, we're going to use this figure here several times tonight, and that's the way it is on all the exam elements here.
Mm-hmm.
If you're in a particular section and they're going to show you a picture, it's going to be the same one for every question. They're just going to ask different things about it. So you can ask me something different about this one.
Okay, I think I will. What type of circuit is shown in figure E7-2? A, switching voltage regulator.
B, grounded emitter amplifier.
C, linear voltage regulator.
Or D, monostable multivibrator.
I think we already determined this one earlier tonight.
I think we did too. We know it's not a switching voltage regulator, so we can rule out A. I'm pretty sure it's not a grounded emitter amplifier. Well, the emitter is not grounded, for one thing. Is not a monostable multivibrator because there's nothing that's making that transistor oscillate or pulse. And we've already seen the circuit. We got a diode right there on the base of that transistor, a Zener diode. So we're talking about a linear voltage regulator, C. And that's what everyone's saying over in the chat room. And it is. Linear voltage regulator. I guess I'm going to ask you this one.
Okay.
I don't have any pictures for it. What is the main reason to use a charge controller with a solar power system? And this is right up your alley here. A, prevention of battery undercharge.
B, control of electrolyte levels during battery discharge.
C, prevention of battery damage due to overcharge.
D, matching of day and night charge rates. Main reason to use a charge controller with a solar power system is to C, prevention of battery damage due to overcharge, because if you overcharge your battery, you'll basically cook it, and it's going to monitor the voltage and shut it off when the battery's full.
I'm going to agree with you. That this is what the chat room is all saying. Everybody's saying C.
Yeah, that's pretty straightforward one there.
I just happen to have one right here.
Yep.
Bought it at Huntsville Hamfest this year.
Have you hooked it up yet?
No. I haven't hooked it up or the solar panel, the portable solar panel.
Well, field day will be here in June. So.
It will. I need to get out there and charge some batteries, and I don't even know if it works. Maybe. Maybe it does.
Let's hope.
Yeah. I wouldn't want to damage my battery by overcharging it.
What is the primary reason that a high-frequency switching type high-voltage power supply can be both less expensive and lighter in weight than conventional power supply? A, the inverter design does not require any output filtering.
B, it uses a diode bridge rectifier for increased output.
C, the high-frequency inverter design uses much smaller transformers and filter components for an equivalent power output.
Or D, it uses a large power factor compensation capacitor to recover power from the unused portion of the AC cycle. Okay. What's the primary reason that a high-frequency switching type high-voltage power supply can be both less expensive and lighter in weight than a conventional power supply. Well, it's not D. It uses large power factor compensation capacitors to recover power from the unused portion of the AC cycle. No.
You know those LPFC capacitors?
Yeah?
Large power factor compensation.
It sounds like a BS capacitor to me. Hey, the inverter design does not require any output filtering. No. An inverter is going to need some good output filtering on it for sure. So, that's not it. B, it uses a diode bridge rectifier to increase output. Bridge rectifier would not increase the output. C, the high frequency inverter design uses much smaller transformers and filter components for the equivalent power supply. That's my answer right there is C. Chat room's all saying it's C. And it is. And it's a higher frequency. You don't need as large of capacitors or transformers to work at higher frequencies. So that right there is gonna make the thing much more efficient and less expensive and smaller.
Like this.
Like
Who would ever thought the 30 amp power supply would fit in the palm of your hand like that?
that's smaller than a cigar box. What is the function of the pass transistor in a linear voltage regulator circuit? A, it permits a wide range of output voltage settings.
B, provides a stable input impedance over a wide range of source voltage.
C, it maintains nearly constant output impedance over a wide range of load current.
Or D, maintains nearly constant output voltage over a wide range of load current. What is the function of the pass transistor in a linear voltage regulator circuit? Well, I think we talked about this earlier as well. I'm going to go with D, maintains nearly constant output voltage over a wide range of load current.
Okay.
Now, and the only reason I could say that is because the discussion we had earlier. So,
Okay.
because that was the function of it.
That's what people are saying in the chat room. That would be my answer as well. And it is.
Again, if you're not careful, you'll learn something in here.
There it is right there. There's the pass transistor.
It's basically letting the amount of voltage you go through that's limited
By the Zener diode there and resistor combination.
Yeah.
Yeah, it's going to be 0.65 volts less than the voltage that's right here.
I'm going to play around with that. That's pretty cool. I think I've got everything except the transistors.
That's a very simple circuit. It's easy to do. You can find all kinds of variations of that circuit.
What is the dropout voltage of an analog voltage regulator? A, minimum input voltage for rated power dissipation.
B, maximum output voltage drop when the input voltage is varied over its specific range.
C, minimum input to output voltage required to maintain regulation.
Or D, maximum that the output voltage may decrease at rated load. What is the dropout voltage of an analog voltage regulator? This is a little, could be a little tricky. Let's see. A, minimum input voltage for rated power dissipation. No, that's not it.
Kind of makes sense.
B, maximum output voltage drops when the input voltage is varied over its specific range. You could think maybe that. C, minimum input to output voltage required to maintain regulations. Or D, maximum that the output voltage may decrease at rated load. Well, I know what the answer is. Do you want to take a stab at it, or
Yeah, I
do you
think
rather?
it's C.
You think it's C?
Mm-hmm.
That's what I think too, and that's what the chat room is saying.
Because I know those little switching regulators that I use in those projects quite often. Well, when I do projects,
Mm-hmm.
I know there's a minimum input voltage to get the 5 volts out for the 5-volt version that I've used. I think it's like 6 or 6.5 volts it's got to have to get 5 out.
But that's not an analog voltage regulator.
No, it's not, but it's still same principle.
Well, yeah.
Well, the same
It's
way,
a-
the LM, what is
Yeah.
it? I forget the number, but the 5-volt one is still, it's got to have a little bit more than 5 volts.
Yeah, 7805.
Yeah.
Yeah. Linear voltage regulator. You got a voltage in and voltage out, and they can't be the same. You got to have more on the in than you do on the out. And there is it's a dropout voltage is what you call it. I was not real familiar with that term, but I mean, that makes sense.
Mm-hmm.
You know, you got to maintain that. What is the equation for calculating power dissipated by a series linear voltage regulator? Is it A, input voltage multiplied by input current?
B, input voltage divided by output current.
C, voltage difference from input to output multiplied by output current?
D, output voltage multiplied by output current. What is the equation for calculating power dissipated by a series linear voltage regulator? I think it's going to, I'm not sure about this, but I think it's going to be C. That's one that seems to make sense to me. Because I think that's how much, that's what would be dissipated as heat. Voltage difference, C, voltage difference from the input to the output multiplied by the output current.
And that will give you,
that seems right.
that will give you a power,
That's, yeah.
and that's the power being lost in that device, which, yeah, will go up in heat. I'm going to agree with you, and so does the chat room.
Huh. Figure that.
Yep.
What is the purpose of connecting equal value resistors across power supply filter capacitors connected in series? A, equalize the voltage across each capacitor.
B, discharge the capacitors when voltage is removed.
C, provide a minimum load on the supply.
Or D, all of these choices are correct. Okay. What is the purpose of connecting equal value resistors across power supply filter capacitors connected in series? I have an answer for this, and let's just go over these though. A, equalize the voltage across each capacitor. Well, these capacitors are in series. All right. So if we put a resistor of the same value across every one, that is going to equalize the voltage across each capacitor because the resistance across each one will be the same. B, it will discharge capacitors when voltage is removed. And that is correct. And you would call that a bleeder resistor.
Okay.
And you do use bleeder resistors in power supply circuits, especially the high voltage ones, because you don't want 10,000 volts hanging around sitting on a capacitor there when you've turned off the power supply and you think it's off. So yeah, that's a good use for it. C, provide a minimum load on the supply. And yeah, if those resistors are across there, that is going to put some small load on the supply when no regular load is connected. So I'm going to say it's D. All of these choices are correct. And most of the chat room is saying that.
Some A's, some D's, an E.
All these choices are correct. So, yeah, chat room, yeah. Little mixed. We got mostly D's, though, out of the answer.
Cool.
One final question for tonight, and I can just tell you want to take this one,
Oh,
especially since you had the first one,
okay.
and it will give you the most questions for tonight.
Well, I got the most buzzers, so.
Yeah. Let's see if you can top that. What is the purpose of a step start circuit in a high voltage power supply? A, to provide dual voltage output for reduced power application.
B, to compensate for variations of the incoming line voltage.
C, to allow for remote control of the power supply.
Or D, to allow the filter capacitors to charge gradually. What is the purpose of a step start circuit? It's got to be D, to allow the filter capacitors to charge gradually. Step start circuit.
So D?
I think it's D. I'm not sure, but I think it's D. That's the one that seems to make the most sense to me. It doesn't seem like it would be provide dual voltage output, not something called a step start circuit. I'm not exactly sure what a step start circuit is, to be honest with you.
Well,
I'm just guessing based off of the wording.
everyone in the chat room is saying D. And a step start circuit is a circuit that, well, you could put a resistor in series with the high voltage power supply. And when you first turn it on, the voltage is running through that resistor. And then after a specified amount of time, a relay will close and short across that resistor so that the resistor is out of circuit. And then the full current is flowing through there. So yeah, it's reducing the current when you first turn it on, and that gives those filter capacitors a chance to charge up to half voltage or whatever, depending on the value of the resistor. And then when it shorts across the resistor, it brings it on up. So when you first hit the high voltage on, you don't blow the breaker.
Oh.
You let it to gradually, the capacitors can come up to half charge or better, and then, switch and take the rest. So you don't get that big surge right when you turn on. So yeah,
that makes sense.
Your reasoning was good on that. So
yeah.
And you do see them in a lot of high power transmitters. They'll do that because otherwise it'd just throw the breaker every time you try to turn it on. You got some big, electrolytic capacitors you're trying to charge up in some of these. And some are, well, not really electrolytic. They're oil-filled capacitors, but big.
Yeah, like some of those big air conditioning.
Oh, bigger than that. Yeah.
Well, we had some big jokers. Some of those.
Yeah, like my FM transmitter. Let's say even the 10 or 11 kilowatt one has got a capacitor. It's rectangular. It's about this wide, about that tall, and about that thick.
Wow.
It's big.
You don't want to touch across that one.
No, you don't. And that's a good reason to have a bleeder resistor across it, too.
We had those on the air conditioner ones also.
That big?
No, not that big, but we had a resistor on there.
Okay. Yeah.
Some of them.
Cool.
Some of them had it.
And that, my friends, is all the questions for tonight.
Well, it was fun. Even though I got one buzzer, it's fun. Learned a little bit.
It was only one.
Yeah, it's okay. Yeah. I'll take the hit. It don't matter.
Well, let's visit with the chat room for just a moment. I noticed Chip said, George, what was the answer to the what the heck is it the other night? Well, let me find a picture of the what the heck is it. Why don't you tell them a little bit about that net and where things stand there.
Yeah, that was on the soundcheck net that we've been having. We started it 141 weeks ago, and when COVID lockdown started, it was something to give hams something to do for a while when they supposedly couldn't get out and everything. So we started that, and it was a lot of fun. We just kept it going. We had the final one this past Tuesday. Tom, WA2IVD, is going to be starting up another net to kind of take its place. It'll be on a Tuesday night, but it's only going to be once a month. It'll be the Tuesday night following the live stream of Amateur Logic, and it'll be basically based off of that show, comments about that or whatever you may have liked or whatever on it. But thanks to everybody that helped to keep that net going for so long, everybody that checked in, all the hams that worked at Net Controls, the guys that supplied their hub systems, JTK, Brad, N8PC, and Jeff, K0JSC, for use of all their systems, and Jeff, W5PPB, for the repeater and stuff that we used here for it, and the Echo Link node. So, but it was kind of time to move on from that one, and there'll be another one to follow. But the question Chip had was about the what the heck is it picture that was on the last net.
Yeah. So most of the weeks we would post a picture on our social media groups and ask, what the heck is it? And we'd try to pick something odd that, not everybody would know the answer to it. And by the way, that first net that Tom will be running should be on January the 17th, Tuesday, January 17th, because we'll be shooting the next Amateur Logic on Friday the 13th of January.
Yeah. So I'm sure he's going to post prior to it. So stay subscribed to the usual outlets that you used before, and you'll see more information coming about that.
Yeah, we appreciate Tom picking that up,
too. That's really good of him to do that. Much appreciated.
So what the heck is it? This is what we're talking about.
What the heck is that?
That is an alarm clock. That woke me up 4 o'clock one morning this past week. I think it was, I've forgotten what day it was.
It's not really an alarm clock.
Well, it acted as one. Yes, because what that is a high voltage rectifier. There's a lot of diodes on there, right here. Ton of diodes, all connected in series on these different boards. Each diode has an MOV across it to catch the surges. This has one tap on the end here. There's another tap on the other end here. In the middle of these 4 boards is another tap. AC comes in here, and one end here is positive and the other end is negative. So the AC goes here, and you have 3 of these. These are called rectifier stacks. You got 3 of these and a FM broadcast transmitter, or a lot of AMs will be like this too, where you got a high voltage circuit. We're using 3-phase power and 3-phase transformers. So you need 3 of these rectifier stacks or blocks here. This one came out of a transmitter that's currently running about 1100 volts for plate voltage. No, I'm wrong. 11,000 volts.
Oh, that 1 0 really makes a difference.
It makes quite a difference. So that was what the heck is it this past week. I may have to do some of those in the future here on, I don't know, maybe we'll ask them on Ham College or Amateur Logic or something.
Yeah, they're fun.
Yeah. I don't always have a good picture, but this one, I thought somebody would get it, but nobody exactly got it. One guy said it was a spark generator, and he was right too. That's as good
sparks.
As good an answer as an alarm clock, because when you reset the breaker and hit that plate on button again, there were a lot of sparks and noise. So, yeah. Not the stuff you want to see. Chip said, I thought it was a stacked filter column. What the hell do I know? Well, you weren't the only one that said that, Chip. Someone else said they thought it was a filter, and it's kind of misleading because those MOVs, there's capacitors that look just like that.
Arnie says how many questions are left, but not. Well, we kind of covered that a little earlier. Not really quite sure.
Let's see. What were we on tonight? E7? E7D tonight. Okay. Here we go. We've done this many, and we got this many left to go.
So we got about a third left.
Yeah, except
roughly.
The last part of this book is not questions. So,
So
actually
maybe,
it is. They do pretty much call away. It's less than a third
Maybe a fourth
left. Yeah. We've done, just a little over a quarter of the
Fractions
questions
are
left.
hard.
Yeah. We're just under 3/4 through them. So,
Cool.
There you go. One other thing I did want to mention, and I didn't have time to really get it together tonight, but we're studying for the extra here currently, but for technicians, and you may know some people who are wanting to test, this pool went into effect July the 1st of 2022. We weren't studying the technician, so I didn't realize that's when it went in, and it goes through June the 30th of 2026. A technician book. I just got the set here from ARRL. I have not looked at Gordo's technician book yet. The ARRL Q&A for tech is basically just the questions and answers and a brief, little paragraph on most of the answers. There are a few drawings in here. I've never really looked at, or I don't know that I've ever seen this version
Pretty small
before.
book.
Pretty small book, but that is a technician study guide there. This one, now, this is the book that a lot of people would ask about and probably want, particularly those that don't know a lot about this type of stuff and want to do more than just memorize the questions and answers. This is ARRL's Ham Radio License Manual. This one is for technicians. Now, I have one of these for the extra, and it is very thorough. I mean, it covers every question in there, and there's not a paragraph about the answers. There's like chapters on subjects in here. If you want to know about something, it goes into really good detail.
Oh, nice.
If that's what you're wanting to do. If you're really wanting the full package and to know everything you can about that subject. That's
always the best in the long run.
That is. So I'm going to recommend this one. If you've got some friends out there that just want to get licensed quick, well, you can send with this or W5YI Master Publishing's book that Gordon West writes.
Mm-hmm.
But if it's someone they're going to want to dig a little deeper, I'm going to suggest this one. I don't think you can go wrong with it. So, would make a nice Christmas gift too. Unfortunately, I wasn't talking about it back then. So.
Yeah, Christmas is over, but you always got your early shopping for next year.
That's the thought, but you better do it before 2026 gets here.
Yep.
Well, any final thoughts before we go tonight, Dean?
No, have a happy and safe new year, and don't drink and drive. Keep it between the ditches, and we'll see you on Amateur Logic around the 15th-ish.
On the Friday the 13th.
Okay, Friday. Hey, get
Yeah.
to wear the hockey masks again.
Yeah. You know, we always look forward to those Friday 13th shows.
Oh, yeah.
It
They're
happens
the best.
much more often than you would think.
They sure seem to, don't they?
Yeah, they do. And I guess I'll say just do your studying and go take an exam. You know, find out where the test's going to be given. Get licensed and help someone else get licensed too.
There you go. That's the thing.
All right. 7-3, everybody.
7-3, everybody. Good night.